Okay. Hello there, all of you. Assalamu alaikum. Today we will be solving February March 20. Let me just. Hello there. Assalamu alaikum. I'm Mr. Saem Today we'll be solving February March 2020 paper P2. Okay. So here we go. You have been supplied with the following files. Okay. Let me turn right. Okay. You really have to read the scenario very properly because in most of the scenarios, in practical, the main extract, the main concept is over there. So don't just assume it's just a random explanation. It's not like that. You work for Tawara Gaming Computers and will be part of the database to store components. As prices of each item can change daily, the price will only be stored in database if an item is in stock. Data about processors and motherboards used by the company but not held in stock will still be stored in the database, right? Your currency, use your local currency and format it to decimal places. Okay, right? Maintain the evidence document. Examine the data in the files, this and this. Analyze the content of these files. Each contains details of the processors made by manufacturer. Combine these files into a spreadsheet that is suitable for importing as a database table. Save the file as this. Right? Okay. So first of all, what we need to do is we have to open up this file and we have to open up the other file, this one. So over here we have manufacturer, models, the speed, socket, cores, threads, and the price. And the other file, which was in Word, we have model, manufacturer, speed, price, socket, core, and threads. Quite the same thing. So what we'll do is we will simply copy the data from here, the model. Let me see, will I be able to? Yes, I will be able to. So I'll copy the model. And I will obviously place what I'll do is I can use go into view, view, freeze pane, freeze top row so that I can see. So what I'll have over here is the model. So I'll place the model. Then we have is the manufacturer. So we place the manufacturer over here. So one by one, slow and steady. Always read the question ahead, go through the files thoroughly. That's the way to attempt. And remember, slow and steady wins the race. That's the way. I'm telling you. I just copied the speed. So obviously I'm supposed to paste it in the speed. Price. So your IT practical is all about producing an output, a relevant output. So you have to think as system analyst and produce the output. Has to be correct. Then we have the socket. Well, at the same time, obviously, you should know what the socket is and where will you find the socket on the motherboard. What's obviously, being an IT student, you should be aware of all this. Then you have the socket. How many cores does your processor have? And within cores, how many threading do you have? So these are your threadings. So when you talk about multiprocessing, it is because of the threading. Here we go. Once you're done with this, you're supposed to save this file as this, followed by your names. So you save it as sender name can be from here. and all that. I'm going to close this file now. Point number 2, each computer processor fits, I'm going to zoom it in because this point seems to be important. Each computer processor fits into a special socket on the motherboard. Different motherboards have different processor sockets. Some sockets fit processors from more than one manufacturer. Okay. A processor can be fitted to many different types of motherboard. Okay. So some motherboards can be fitted with different types of processor. Okay, both things. The motherboards used by this company are held in the file 20 motherboard.csv. So this is what we have. Over here we have the information about the motherboard, the manufacturer of the motherboard, the model, the chipset that it consists of, sockets, the memory, okay, the slots, and the price. And analyze the content of this file and the one that you just saved in step 1. So in step 1, we just saved this file, as you remember. So here we have the manufacturer, the model, the speed, socket, cores, FZs, and price. This was about your processor, by the way. Right. So this information is about your processor. The other information is about your motherboard. You will plan and create a relational database. So we have to create a relational database to store the data for the processors, motherboards. Create a data dictionary in your evidence document and include details of the table, records, fields, data types, and any other relevant data. So we'll talk about the data dictionary afterwards, but first we have to focus on creating a relational database. Now, this is a bit more challenging. It's something related to normalization, but because you have to make appropriate relationship between these two tables, and you have to create. Okay, so you obviously can do this by creating another table. Okay. So as you can see, is we don't have any relevant information over here. We can make the model of the motherboard as a primary key. We can make the model within here as the primary key. I can just delete these two. But still, the model of the processor is different from the model of the motherboard, as you can see. None of them are the same. We cannot use the manufacturer. We cannot use the chipset, obviously in the memory. So we don't have relevant information right now that can relate these two tables. One thing that is common in these two tables, if you do deep analysis, quite a deep analysis, you will find is that obviously your processor has a particular socket number, and the same socket number is used for the motherboard, and that particular processor fit on a motherboard's socket. So socket over here and socket over here, they are quite the same. But how will this help us? We cannot create many relationships. Don't think of creating a relationship between this socket and the socket. That will end up making many to many. But before I discuss this further, what we'll do is, I think so I just did not save it. Just give me 1 second. I was supposed to, I just removed the 2 rows and I did not save it. I did? Let me check it here. No, I did not. So I don't want to do this in XS. So I'll just save it. Now we'll simply go into XS and we'll import it. Then I'll talk about it later on, that how a proper relational database can be created. How can this be done? Obviously, when the examiner is giving you 26 marks just to create relationship, there has to be something which requires a lot more thinking. So we have over here the first file that we integrated 2 files with. Obviously, I'll come into price and I'll make this as currency. Price is currency. And what I will do over here is As you can see, the socket is appearing on the left-hand side. I could use the socket as a short text. Okay. Let me just go down and see. Right. So we can choose the model as a primary key. No error. Let's import the other one. The other file that we have to use is the motherboard file. In the same manner, we'll make sure that the price is currency, and we'll make sure the socket is short text. Because the socket consists of AM4. Now I'll make the model as the primary key again. Now you can see I have two tables over here, but what can help us to make the relationship is the socket over here and the socket over here. But like I said, we cannot make man-to-man relationship. So what can we do? Well, what we can do is we can make a third table where we simply have socket, and we can just have socket as unique key, as a primary key, and then we can relate that primary key one to many, and the same one socket. So we'll just have one table in which we'll just have one field as socket, where we will have is only socket as a primary key, and we'll have all the unique sockets over there. Now, why are we doing this? I'll tell you why. This is where you get rid of redundant data. When you will have a relationship of one to many, you are going to get rid of redundant data. So you'll be eliminating unwanted data, repetition. And you will see how will I do that. So the best way to do this will be, I have to look at two things. I have to look at sockets over here and the sockets over here. Are they quite the same? Well, let's have a look. So I'll simply add is the motherboard. And from here, I'll simply add is the socket. I'll click on total. And I'll just run this. You will see is I get all the unique sockets. Okay, I get all the unique sockets. What I can do is, I can simply say make table, and I can name this as socket or sockets. Now if I run this, it will tell me you're about to paste 21 records to a new table. Do you want to do so? I said yes, I want to do so. I don't want this anymore. So I get the sockets over here. But I just want to be sure about one more thing. I have the other table, and I would like to see are my sockets over here. Do I have an extra socket over here? Because in motherboard I have separate sockets. Because if you look at the question talks about some socket fits on processors. Okay, some processors can be fitted to many different types of motherboards. Some motherboards can be fitted on different types of processors. So obviously, the sockets, the different motherboards have different processor sockets. So you have sockets in the motherboard and you have sockets in the processor that fits on the motherboard. So you have to look at both of them. So I'll come over here and I will simply now add is the processors, and we will see now, and we'll see how many do we have here. And what I would do is, the easiest way, like I said, I just told you in IT paper, you just have to find the relevant way how to solve the problem. So if I simply just arrange this in descending order, I'll be in a better position to see it is already, and then I have this in descending order. So I have over here one, so see, it's quite easy to check because there aren't many. Well, there is another way that if this question had lots more, we could have used the query wizard. I'll tell you afterwards. Let me first do this. So I have 1150. I have 1150, I have 1151, and I have 1151. Then I have 1155. Then I have 1155. Excellent. Then I have 1440. I don't have 1440. So what I'll do is I'll just copy this and I'll add 1140 over here. Then I have is 2011. I have 2011 over here. And then I have is 2066. I have 2066. And then I have is AM4. And I have is AM4. So this means we have And in this particular, I have all of them. Okay, so I have all of them. So I can close this. I don't need this anymore. So in this sockets, I have all the sockets which are 22, as you can see. So we have a table now sockets that can help us to make a relationship. And obviously what we can do is we can make this the primary key, and there is no harm. We can obviously do it. The way I was talking about, if you could catch me what I'm saying, is if I come to query wizard, there's something known as unmatched. Unmatched query wizard can be used to compare two tables and compare for example, if I want to compare socket in one table with the sockets in another table. For example, if in the processors, I had multiple sockets that I had to compare with this socket. Okay, so I would have named the other table sockets and named this as socket and compared this socket with that socket. And if there were any multiple sockets that were not present in one table and were present in the other table, this would have worked. But since there were just few, so manually could have been done. So there's no problem with that. Okay. This I'm just talking about if that was the case. So I now simply add all of these, and we will just try to make a relationship. So yeah, bit tricky, bit challenging, but not a lot, I would say. I just have to think, read the scenario. I keep on saying read the scenario thoroughly, carefully. You will end up with something good. Try to find what is common between the tables. You will find it out. You can make it in tables. You can just have to find a proper way to solve the problem. So socket and socket, one to many. Take screenshot of this, place it in your evidence document, and socket and socket, you have one to many again. So here we go. So we have been able to do part number two, your data dictionary. So as far as data dictionary is concerned, you need to show is this. And so you have to give a screenshot of this, and you data dictionary also includes your table name, your field name, your data type used, okay, and validations as well. So you can apply appropriate validation rules over here as well. For example, in the memory, you can apply a validation rule DDR or DDR2, DDR2, DDR3, DDR4, DDR5. In the slots, you can have a validation rule that would say is greater than equal to 1 and less than equal to 8. Okay, so on and so you can apply different validation rules on different fields as you know how to apply it over here. So you'll apply multiple validation rules on this table. You will apply multiple validation rules on this table. It's up to you. Whatever you want to do, it should be relevant. And you will take a screenshot of all that and you will place it in your this document. This is the way you will do your this particular point. Using the data dictionary and the file saved in this create database, we've done that. Okay. Create a report for a customer who requires a list of all i7 processors with a speed of at least 3.7 gigahertz and motherboards that are currently in stock that support these processors and support DDR4. The report must include all the details of the processor and motherboard. Okay, all the details of the processor. Do not show any duplicate records. So let's try doing this. So we need to have all the detail of the motherboard and all the detail of the manufacturer or the processor, right? So you can see over here is, no, there's no duplication because this and this are different, right? Let's read again. Okay, so create a report for the customer. Okay, right. So create a report for the customer, which requires a list of all i7 processors. So i7. So how do we do i7? That's in the processor. I'm sorry, where was it? What is the name of the field? The model of the processor. So we'll have over here is star i7 i7 star. Star i7 star, if I've written it right, would mean to find i7 wherever it is. At the same time, with a speed of at least 3.7. So as far as the speed of the processor is concerned, talking about the speed of the processor, we should be at least, so it should be greater than equal to 3.7. Right. And motherboards that currently in stock that support these processors and support DDR4. So we have to use motherboards that have memory, which is DDR4. So we're talking about motherboard. Please make sure one thing, that the criteria that you're typing should go in one line, because when you type in one line, it means the and. If you type diagonally, it means the or. I've talked about this number of times. So if you commit a mistake over here, it will be a blunder. Okay. Right here, currently in stock, right here. Yeah, so those which are empty are basically not in stock. So what we'll do is we'll make the price is not null. Okay. So we'll have all which are not null, as you can see over here. And then what we have is, let's read more. Okay, they're currently in stock and that support the processors, right? This report must include all the processors, motherboards, fine. For each combination of motherboard and processor, calculate the total price. We'll just do that. Group this report by processor model and then by motherboard manufacturer. Include all the processor details in each group header and the motherboard except socket and total price in the body of the report. Okay, in bold the total price, right? So here we go. What we can simply do is, we have the detail, we can just create a report. Here we go. Obviously, we can create this report in landscape because we'll not be able to fit it otherwise. So here we go, one by one. Have they mentioned? I didn't read. Let's read. Have to talk about it. The report must fit on a single portrait wide and font and appropriate font size. So we have to make it as not landscape, as portrait. So let's see, it should fit if they're saying so. Appropriate font size. Okay, so let me just close it and let me just try look at one more thing. Why am I getting empty here? So we should also have is not null over here as well. Is not null. Okay, so right now we can simply create a report. Obviously, if they've not asked you to fit it on one page wide, then it's perfectly fine. You can just leave it like that. But if they say it should fit on one page wide, then obviously it should fit on one page wide. Well, I can keep on doing this afterwards. We need to group this report by processor model. So we'll first of all group this by process. calculate the total price of the two items. Okay, we had to create a new field at runtime which will calculate the total. I mean, since you can do that. Okay, so group this report by processor model, then by motherboard manufacturer. So here we go. So right click on this and group on processor model, and then the manufacturer of the motherboard. So this is your motherboard manufacturer, and you group with this. And then you had to calculate, include all the processor details in the group header and the motherboard details except socket and total price in the body. All the processor details. Right? In bold the total price. So we need to have I didn't do this part. I hope you can try yourself. The total price was supposed to be calculated runtime. Okay, so all you had to do was, for example, this was a price. Right click, go to total, and calculate the total sum of that price, and you'll get it below. Right. What else? All done. Right. So see you in the next lecture where we can. Oh yeah, export this report into PDF file formats. Once you have this, obviously you have a way of exporting this into external data, export more into, you will have PDF. Yeah, you can export into PDF. So you have sound video editing. We will discuss that later on. Okay, see you all. Thank you.